Okay, so here we go. There's 5 topics that we're going to be on the exam. I've attached the practice test on the email, and these are just selected. So if you see a number here, it's off of that practice test. All right, so the first thing we're going to ask you is something on those geometric means. This was from section 8.1. It seems like a long time ago. And remember, it had those 3 patterns. I'm only going to give you 2 examples here. These are the 2 primary patterns. One pattern deals with the middle, the other pattern deals with the left and right side. So let's see how much of this you remember. One word of caution, as always, since I'm talking to myself basically here, I'm going to go pretty fast here. Remember the power of watching the videos. You can always rewind it. And then secondly, I'm going to offer this to you. If you don't feel comfortable with this practice test, we can take another day and do another practice, but please send me an email so I can help you, and I can, give you more worksheets or something like that to help you, or send you another video on the topic you need. So here we go. Geometric means. So remember, this had that shape that was constructed with a right triangle, and through the 90-degree angle of the big triangle there, you make an altitude. Now notice these 2 examples here, that setup has been swapped around slightly. So if you need this, then we'll do example number 1 here first. Then you need to turn the shape so that it faces as we drew it in our book of truth. So I literally just flipped the image around, and now it looks like that. And so now we can see that pattern. So notice the information, we've got the middle piece, and so that was that first pattern. And so that first pattern, if I use colors, which would be blue, is equal to the square root of red times green. So blue, this is the geometric mean. Remember, geometric mean is the square root of 2 numbers multiplied together. So 48 is going to be equal to the square root of 64 times x. Now, I could write x times 64 as well, too. All right, so how do you solve this for x? Well, since x is on the inside of a square root, we need to square both sides to get rid of the square root so we can have access to the x. Okay, so these are going to be big numbers, but remember, you can use a calculator. So I squared 48 and I get that number. Squaring a square root cancels both the square and the square root. So I'm left with 64x. Simple problem here. Divide both sides by 64, and we get x is equal to 36. Okay, and remember, there were 3 patterns. The second and third pattern are basically the same pattern, just one's from the left side and one's from the right side. So if I take example 3 there and flip it so it looks like it does from our example, you can see that I'm doing the pattern from the left. So that would be where the 15. So let's use colors again. So blue would be equal to the square root of the whole darn thing on the bottom. That would be red, times green, which is the short piece. Now, if that 15 had been on the right side, the only difference is the green would be that piece there on the right. Hopefully that made sense. All right, so let's plug in our numbers here. So let's see, 15 would be equal to the square root of the whole darn thing is called x, and the smaller piece there, you got to realize it's been flipped, so it looks like a 6 there, but it's actually a 9. Look back at the original problem before I flipped it. All right, so let's see, same drill here, we square both sides. 15 squared is 225. Squaring a square root cancels the square root. Divide both sides by 9, pretty straightforward. All right, so those are the only 2 examples. I gave you a bunch of problems on the practice test, but those are the 2 patterns. Like I said, the third pattern would just simply be that, look at the one there on the right. The blue would be on the right side, and so would the green, but the red would still be there with the red. And if you did 8.1 and you had no issues on 8.1, this should be no problem. Okay. Second topic on the test will be the Pythagorean theorem. Straightforward, no surprises here. One example of each, example 5 and 6 from the practice test. One where we're solving for a leg, and one where we're solving for a hypotenuse. So remember the Pythagorean theorem, a squared plus b squared equals c squared, where c is the side that is opposite the right angle. So for me, I will always, so I don't screw it up, I will always draw an arrow from the 90-degree angle to the opposite side, so that I'm 100% sure what the value of c is. The other 2 values, you can put them a, b, it doesn't make a difference. So if I made x to be the a squared and 6 to be the b squared, so that would be x squared plus 6 squared is equal to 10 squared. Remember, we're going to square everything. 6 squared is 36, 10 squared is 100. Do a little bit of algebra here, subtract 36 from both sides, take the square root of both sides, and we get x is equal to 8. So that's solving for a leg. The only difference for solving for hypotenuse is, well, it actually is a little bit easier because the c squared is going to be what you're solving for. So all we got to do is square a, square b, add them together, and then take the square root. So let's see, a is 12, b is 5. The c value is opposite the right angle, so that would be the x. Square everything, add 169, take the square root of both sides, and we get 13. Once again, if I'm going too fast, rewind, watch it a couple times. All right, the next drill we did, which was part of that same lesson there for 8.2, which is, or was 8.3, do 3 sides make a right, acute, or an obtuse triangle. So here's what you need to remember. Now, I'm only going to give you 2 examples. 3 possibilities. If a squared plus b squared equals c squared, it's a right triangle. If a squared plus b squared is greater than c squared, well, then it's a acute triangle. And then lastly, if a squared plus b squared is less than c squared, then it's obtuse. Critical that you have this in your book of truth and you have those things written just as I stated. Now we simply just need to plug in the numbers and see the relationship between the left side and the right side. Remember, the biggest side will always be C. So on example number 9, so 13 is bigger than the other 2 sides. That's going to be our C value. I throw that into a squared plus b squared equals c squared, and we see what we get. So that's 11 squared plus 5 squared, 13 squared. So that's 121 plus 25, and 121 and 25 is 146. And 146 is not equal to 169. It's smaller. So I'm looking at the top there. If it's smaller, that makes it obtuse. Okay. You will not be able to look at the triangles and determine whether they're obtuse or acute or right. Simply by looking. Every triangle they're going to give you is going to look like it's a right triangle. All right, number 12, let's see. The biggest side, if it's a right triangle, would be the C value. So that means the other 2 sides are 4. So throw the 4 in for A and B, square everything. 16 and 16 is 32. 32 is not equal to 25. It's bigger. Therefore, that makes it acute. I can't make this too challenging because this one's pretty straightforward. All right, topic number 4, running through these real quick. If there's a topic that will give you issues, it's topic 4. Topic 4 is the special right triangle ones. All right, so let's see how this works. Remember, there's 2 types of special right triangles, one a 30, 60, 90, and one a 45, 45, 90. Now, I will just warn you, they love to use all sorts of variables for the unknown sides. Look at 15, they're using A and B. Look at 16, now they're using X and Y. Look at 17, they're back to using A and B. But here's the caution note. Our basic 30, 60, 90 from our example, there it is right there at the top, use the value A. Right? So even though our example uses A, the problems may or may not use A, and there's no requirement that they put their letters the same way we use our letters. So if there's an issue with special right triangles, it's trying to be able to figure out, well, if they use A, is it the same A that I have from my example in the Book of Truth? Okay, look at question number 15. It looks like their A value, right? I'm not literally their A, because their A is on the hypotenuse there. But if we look at our at the very top there, A is the side opposite 30 degrees, and that side is 8. So in this case, A is 8, but be careful. That A that I just quoted is that A on our example. Boy, is this confusing, right? Okay, so that A is 8. So if we try to match up the letters now, well, let's go to the hypotenuse. The hypotenuse on both of those, well, the hypotenuse on the basic one is 2A, but the hypotenuse on 15 is A. But since we know that we just said that A was equal to 8, so 2 of those would be 16. The B value there aligns with A root 3. Well, since we know that A is 8, so that means B is equal to 8 root 3. And as I stated before, the A value on question 15, I realize this is confusing, right? On our triangle is equal to 2A. And since A is equal to 8, 2 A's would be 16. All right, you need to wrap your head around that, right? All right, 16 is a bit easier simply because they use X and Y. All right, so let's see, X and Y, what matches up? They will always only give you one number. They give us 18. So let's see, 18 matches with the 2A. So I can now solve for A. So clearly A is equal to 9. Now that's the A on my original, the one from the Book of Truth A. Now let's see, what does that match up? Well, that matches up with Y. So that means that that is equal to y. So y is a, so therefore y is 9. All right, so I just need to figure out what x is. X is equal to a root 3. And since a we just figured out was 9, then x is 9 root 3. Okay, with x's and y's, it's not as confusing. But boy, is it confusing with a and b's. So let's do one more with 17. So if we look at 17, this is the nightmare one. This is where we get that long leg. We see the long leg is 2 root 6. All right, so if we look on our one from the Book of Truth, the long leg is equal to a root 3. So that means that a root 3 is equal to 2 root 6. And now I have to solve for a. So that means I got to divide both sides by the square root of 3. So I'm going to divide both sides by the square root of 3. But remember, we're not allowed to have a square root in the denominator, so we got to multiply the top and bottom by the square root of 3. All right, be careful with this. Square root of 3 times the square root of 6 is the square root of 18. The square root of 3 times the square root of 3 is the square root of 9, which is 3. So we get 2 root 18 over 3, but be careful, inside of 18 is a 9 times 2. So the square root of 18 is 9 times 2, and the square root of 9 is 3, so you pull that 3 to the outside, and that would be 3 times 2, which is 6. If that was too fast, rewind, listen to that one again. So now we know what a is. A is 6 root 2 over 3, really not a friendly number. Now let's match that up. What letter is that on our example number 17? Well, a on our Book of Truth is the bottom, the short leg, and that is the b value. All right. Oh, I'm sorry. There's one more simplification we can do because 3 goes into 6 twice. So that would be 2 root 2. There we go. All right. So back to my original statement that a is equal to the b value in our example number 17. So that means that 2 root 2 is b. So we just need to do the a value for 17. So the a value of 17 is double a, and double a is 2 root 2 doubled, and that would be 4 root 2. Wow, that is absolutely confusing with A's and B's. And unfortunately, it is what it is. You just got to wrap your head around it. All right. Remember, we have a second type of special right triangle, 45, 45, 90. Same drill. I've got one there on number 18 that uses N and M. And then number 19 uses an A and B and, just mess with you. It's not too messy for number 19. All right, so let's see how this works. So at the top there is our from our Book of Truth for 45, 45, 90. The two legs are each a, and the hypotenuse is a root 2. So let's see what we got here for number 18. And we got the value 6. Hey, that means 6 is a. Well, look at our original thing. And so if 6 is a, that means letter N as in November, is also a. So that means N is also 6. We just got to figure out M. Well, M, look at our Book of Truth, is a root 2. And if a is 6, then, well, geez, M would be 6 root 2. 45, 45, 90s are always easy when they give you the a value there. Same thing with 30, 60, 90. If they give you the a value right there, the rest fall pretty quickly. Excuse me. So let's see, number 19, they gave us the 4 value. So 4 is equal to a root 2. We just got to solve for a. Same drill as the previous time, where we have a square root attached. We just divide both sides by the square root of 2. We got to rationalize the denominator. So multiply top and bottom by the square root of 2. So we get 4 root 2 over 2 times 2 is 4. The square root of 4 is 2. So we get 4 root 2 over 2. So that's just, well, it's 2 root 2 again. All right. So that's what the a is. And a matches up on number 19 with the b value and also the a value. So even though that is called a, and on our number 19, that's called b, right? That means not only is a, but b is 2 root 2 because a and b are the same value on a 45, 45, 90. 45, 45, 90. Okay. So if there's something you want to replay over and over again, it would probably be the special right triangles. Of everything on the test, unless you're, you got your head fully wrapped around this is the most challenging thing of the test. All right, so we'll finish up with topic number 5. That's solving for or doing trig problems. It'll be both solving for a side and solving for an angle. So here's 3 examples of solving for a side. Critical that you have SOHCAHTOA written at the top. Can you see that? Or is my name in there in the way? Okay. If my name was not in the way, it was on my screen. So we need sine, cosine, tangent, so SOHCAHTOA. And then here's my suggestion. Now, you can either literally do this or you can think about this. So look at 21. Start with the angle, right? So if we start with the angle, label the variable and the side that we're given. So let's see, x would be on the 10 would be on the opposite side, and x would be on the hypotenuse. Look, it's directly opposite the 90-degree angle. So let's see, which trig function uses opposite and hypotenuse? That would be sine. So sine of 66 would be equal to the opposite side, which is 10, over the hypotenuse, which is x. This is that one with the variable in the denominator. So the trick is to multiply both sides by the value x. On the right side, now the x's cancel. On the left side, you're left with that. And to get x by itself, we simply divide both sides by sine 66. On the left side, the sine 66 cancel. You're left with that. You grab your calculator, make sure you're in degrees. 10 divided by sine 66. It's going to be a decimal. You're going to have to round. So approximately 10.9. I'm looking at my triangle on 21. Well, if the opposite side is 10, the hypotenuse has got to be bigger than 10, and it is. It's 10.9. So it's a reasonable answer. All right, the middle one. Let's see. Once again, we start with the angle, and we label. Let's see. 11 would be the opposite side, and x would be the adjacent side. Well, that would be tan. Tan is opposite over adjacent. So tan 22 is equal to 11 over x. Same drill as the previous problem. We got x in the denominator. So multiply both sides by x. The x's cancel on the right side. To get x by itself, we divide both sides by tan 22 now. The tan 22s on the left side cancel. So x is equal to 11 over tan 22. Grab your calculator. Away you go. Round. I believe on the test it doesn't specifically say, but round to the nearest tenth would be good enough. Let's see. Is that a reasonable answer? Let's see. The opposite is 11. It's the smaller of the three sides, so it sounds reasonable. Last one. Let's see. 27. I got an adjacent and hypotenuse, so that would be what? Cosine, adjacent, hypotenuse. All right. Oh, look, a nice one. We got a variable in the numerator. So we just simply multiply both sides by 12. The 12s cancel on the right. Plug that sucker into your calculator, and there you go. Reasonable answer. Sure, it's smaller than 12, 10.7. There you go. So that's solving for a side. I gave you a bunch of those to practice with. These should not give you any problem as long as you remember sine, SOHCAHTOA, sine over sine, cosine, and tangents ratio. Second thing you do with trig is solving for an angle. This is the one that's going to use the inverse button. All right, let's see how this works. Same drill. I don't know why they put question marks. I wish they put X, but they didn't, or theta, either one. But they put a question mark. It's still, I'm going to write those on the top. It's still SOHCAHTOA, but technically we're going to be doing the inverse, but it's the same ratios. All right, let's see how this works. We go to the angle. We label if we need to. Let's see, that's opposite and hypotenuse. That's sine. So sine of the unknown angle x, we'll call it, because I don't want to write a question mark, will be 40 opposite over hypotenuse, 47 over 58. To get x by itself, we need to do the inverse sine of both sides. Remember, inverse sine gets rid of the word sine, but it's going to get rid of everything but the x. So on the left side, sine and inverse sine cancel. You're left with x. And on the right side, that's what you plug in your calculator. Remember, we get to that inverse button by using the second function on our calculator. This will be an angle measurement, so make sure you put degrees. And I rounded to the nearest tenth. I don't remember what the instructions say, but rounded to the nearest tenth, you can't go wrong. All right, the middle one, same drill, the angle. Let's see, I got adjacent and hypotenuse. Adjacent and hypotenuse is cosine. So cosine of x is equal to 33 over 50. To get the x by itself, we do the inverse cosine of both sides. The cosine and the inverse cosine cancel. You're left with x. Do the inverse cosine of 33 over 50. That's what you plug in your calculator. And I'm getting about 48.7 degrees. The last one, let's see if we did sine, cosine. This better be tangent. So let's see, opposite and adjacent. Yep, that is tangent. So you can screw this up by putting the numbers in the wrong order. But, you know, as long as you have SOHCAHTOA and you're looking at it, should be pretty straightforward. So let's see. Opposite's 46 over 44. Do the inverse tangent of both sides. We've done this drill a bunch of times now. Tangent, inverse tangent, cancel. You're left with x. Inverse tangent of 46 over 40 into your calculator, and we are done. All right. So that's your quick down and dirty review for the test. As I stated before, if you don't feel comfortable and you're getting these wrong, absolutely send me an email. We can do another practice day if necessary, or I can answer some questions or whatever. But if you're ready to go, then I will post you. I'm going to send you the test on let's see, this is the Monday class, so I will send you the test. I will probably send you the test Tuesday morning. Go ahead and this is on the honor system. Go ahead and take the test. Send me a copy. I trust you, Cassie. Send that to me. I'll grade it and tell you what you got on it. All right. So that will be it. Wrap that one up for the test prep. Good luck. And I'll see you for another class, not on Tuesday, but I will see you on Wednesday.